Hello and welcome to this new tutorial, and today's topic will be how to simulate electronic failures or calibration or mapping issues on a LED wall. Why, you ask? To put pranks or whatever, or to put a good ambience on the stage, but it will allow us to learn some things along the way too. So let's create a new project and simulate the stage that we will have in front of us. So let's call this project whatever. All right, and here it is. Let me remove that from my face. Okay, so now I'm going to simulate the LED wall that we will have in front of us, and it will be constituted of LED tiles, LED modules of 64 by 64 that we bought on Wish. So let's customize that, and let's say that it will have a 64 times 10 module in width, and let's say 64 times 6 module in height. I put an even number here because you'll see later it will be useful. It will be useful just now, because now we are going to change a little bit the test pattern that we have in the show to reflect the size of our LED tiles, and for that I'm going to change the grid size to 64. So now each one of my square here are 64 by 64 pixel. So I choose an even number here, because if I had chosen an odd number like 64 times 5, for instance, the grid will start halfway, which for the purpose of this exercise is not what I want. So let's add another line here. Okay, so this video will be structured in mostly 3 parts. First, I'm going to show how to simulate dead pixels, then how to transform this composition into like connection cable issue, and then we will see a little bit how to scramble the mapping and to make some calibration and latency issues. So first I'm going to go into my pipeline and my content map here. I will, in my content map, with a right click, I will add a content area that will take all the size of my content map. And I will add a mask here. I will add a mask to simulate like one part of the electronic. So here, let's say, for instance, let's go in pixel mode. And let's say that one of the electronic is half left and half right of the LED wall. So let's go in stretch to fit in my placement mask and put that in 320. And let's put the anchor point in the position and dressing to 0, 0, 0, 0. So here we have the mask that you can see here that will represent one of the electronics of my LED wall. So let's create a new composition in the show. And let's start to create the dead pixels. So important here, I will create some modifiers afterwards, and I will always use them in a composition. While because the composition that I send to any target, like here in the content map, will take the resolution of my target. And as we want to do things that are like precise and pixel perfect, we want to have a correct resolution defined in the composition on which we are going to apply the effect. So if you see here, if I change the target of my dead pixel map to content area, then here the resolution will change. So now in this composition, I will create a little setup to create my dead pixel that will be constituted of a 3D plane, like that, and a camera. And the camera, we are going to rotate it in its placement to minus 90 degrees. Minus 90 degrees. Okay, let's augment a little bit in the generator the size of the plane to make it take the whole screen. Now when I say the whole screen here, I'm sending my composition through my content area. So to see exactly what is going on here, let's rename stuff, like in this one, electronic 1, And let's put a little label to both of them, this one orange and this one red, for instance. Okay, and so this color label will reflect on the element tree, which is easier. So here my plane is taking my whole composition. If I look at it, it's what is happening. But here I see it only on half of the composition because I send it through my electronic number one here. So now let's scatter some point over the plane. So something that you must be aware of is anytime just Ctrl-Shift-A to add a renderer and suppress one. It will allow to avoid some bug that there is in the 9.3.6 version, but probably it's solved in the last beta version. That sometimes does not allow really to add another renderer, so whatever, just let's add a renderer and suppress one, and now let's add a simple point renderer. So the simple point, what it does, it just creates a pixel that will be always to the size defined here. It doesn't give a fuck about the depth of my composition. So now let's put this point in red, 100%, and let's add on this plane a little operator that will be a random point. And let's deactivate with spacebar or suppress the surface renderer. So now what I can do first is expose a little bit the parameter of my number of points. Expose as positive number, for instance. So I have like access to it directly here. And what I can do also is simulate with a dead pixel, or I can also just add here on the seed a little linear loop that we can parameter by clicking here in function to 0 to 100 seeds to make some kind of scramble pixel like that. Up, and here it is. And what we can even do is put an exposure at this one, so we have both our parameter here, so we can stop that to 0, reduce the number of points, and do whatever we want. Of course, you can add another point renderer here and change that to like let's say green. Okay, and add a little 3D transform there and move that in another position if you want to. And here the number of points will be done on both will be reflected on both my renderer, of course. So from this dead pixel stuff, what we can also do is simulate that we have dead pixel only on one tile or in a row of tiles. To do that, we can either, let's add a little bit more point. You can either add a mask here, so placement mask, and put this placement mask actually in 60 by 64 by 64 pixel. Like that, and place it to a multiple of 64, for instance 64 times 2, 64 times 3, up, and here we are. You can also expose this value if you want to find a tile very quickly. So for instance, I have tile of 64, so if I do an expose parameter here, and I will expose that as horizontal canvas value in pixel, and we will add a little modifier here, which will be a multiply, and we set that to 64. And then here, my position, if I put 1 in X, or 2, or 3, or 4, it will automatically place on the correct one. And if we do the same in vertical, it will do the same. So let's do that in vertical, expose as vertical canvas value. Let's duplicate the target, Ctrl C, Ctrl V, and now 1, 1, so I mean 1, 1. Here we have a little shift because of course we multiply 1 by 64, my anchor point it has 0, 0, so there it is. But that's an option, and what you can do also is to remove this mask and to use simply 2D layer mask. So mask, layer mask, change the mask map to a checkerboard, and in the checkerboard, in the generator, you have here the size of the lines. So here you can put like 64 by whatever, and you have like one row out of two. So whatever the failures of the things that you want to simulate, you can also do that this way. To discriminate on which LED or row or you want to put them. So now from these dead pixels here, let's simulate connection issue. So let's create a new composition in the show. 2D layer, composition, let's call that connection issue. It's maybe more a calibration than a connection issue. I'm not a technician, LED technician. Actually, I know a little bit how it works because that's my line of work, but not sure about how every calibration software or every LED wall worked. So let's put an example image from the standard pack in texture example image. And let's take this one, for instance. Up, all right, Control-Alt-O to fit outside. And let's create this kind of electronic, let's create dead pixels, or not really dead pixel, but one bright spot on the edges of the image. So to do that, on my composition here, I will add a renderer that I will specifically send to my electronic one, and call that a renderer glitch. So now I have two instances of my composition, one that is sent in the full content map, and one that is sent only on the glitch part, one being over the other. Here is the glitch, it's here. So now let's add a little compo based with utility compo based, here it is. So compo base, I made other video about how it works, so I will not retell everything. But we are going to use this composition, dead pixels, and put everything inside of this. So let's duplicate this one because I want to keep my dead pixel, original dead pixel composition. And let's put everything into this composition, into this compo base. Up. So the plane and the perspective camera, yes, and let's suppress this one because we don't need the mask. We will use another kind of mask, and a lot of error here. So here what my compo base does actually, it reduces the same composition that I had before, so I can augment the size of my that's the speed, my density of point, and my placement mask, of course, it does not work anymore because I suppress this motherfucker. But we have a parent input there, and what we are going to do actually on the plane here, up, let's remove that, and let's put that as black, so we see exactly what the compo base does, this for now. And I remove the alpha layer from the compo. And that's what we are going to do in this plane is colorize the point with a colorized texture layer. And in this colorized texture layer, we are going to take the parent input. So what that means is now the color of my point is somewhat multiplied by the color of the parent input, which is the image that we put in our composition. So if I add a little bit of exposure here, for instance, maybe you'll be able to see a little bit more. Yeah, you can see a little bit the shape of the mountain showing around. So what I will use here is a stylized modifier that is called the Sobel. So what does the Sobel does? Let's put the Sobel in white. It creates edges on the image. I'm not sure if I can visualize that. Yes, I can. Here. Come on, put my background in black. So here the Sobel, what it does is just delimitates the outer edges, and that's very fine because I use that as a color masks, which means like all my dead pixel will be multiplied by a white line, so remain, and multiplied by black by alpha, which is the same as black, and so they will disappear when they are outside my image. And let's put back the parent input. Let's augment a little bit the density of points. And here in the Sobel, you can change the threshold, like that. You can change the size of the line. You can be calm. Okay. And you see that we have a little bit of here a little bit of offset between our two layers. It's just because the plane should be set it up in the composition exactly where my image is, which is not very efficient. So what we are going to do is just add here a little camera mapping, UV camera mapping modifier before the random point, after the random point, maybe better. And then let's put the perspective camera inside of this. Okay, so it's just a little trick, but voila, it's just this trick, creating this UV camera mapping and takes the camera that is inside of your composition will ensure that we have the correct mask that work properly. And so here, if I take a little example image, video, sorry, so here I should have some, like the smoke. Up, let's play that. Control-Alt-O. Control-Alt-O, and put that into screen. Okay, so here you see around the outer edges of our smoke that we have this kind of dead pixel. Not dead pixel here, it's not a dead pixel simulation, but this kind of things appearing, which I saw quite not a lot, but from time to times on a LED screen. Maybe the sobel should be a little bit thinner to make it more believable. But yeah, that's how you can do it. And now let's review the last thing, which is the mapping, module mapping issues. So to do that, let's create a new composition in the show, up, and call that mapping issues. So in this one, I will take the test pattern. So we will see exactly what goes how. And on the test pattern, let's add those two little scan lines. Put them in 2 pixels maybe. Okay. And let's add a little image. So from my example image, let's take the same. Here it is. And let's put the test pattern in additive mode. All right. Control-Alt-O. Thank you. Now what I'm going to do, same thing, Control-Shift-A on my composition and send what in the electronic that I want to make a glitch. And let's add my favorite modifier, the 2D transform, and add a random offset in position, vertical and horizontal, something like that, for instance. Okay, and let's make insert that on each of those tiles here. On each of those tiles, I will have a different offset. So let's remove the test pattern and put a new one above everything in the show here in content map, so that we see we keep the actual test pattern to see what's happening on the image. All right. So on this glitch renderer, we add the 2D transform, sorry, and let's add over that a little mask that will be a layer mask that we change to a noise mask. Where is the noise? Alphabetical order, and here it is. Now let me divide that into divide my viewport, so we can see how the mask look like and how the result looks like. So that's what you have here. So let's reduce a little bit the noise, and let's add some contrast, brightness, contrast gamma, and contrast PIF. I did that to be sure to have like a very black and white values, to be sure that my deformation will be taken at 100% in black area and at 0% in white area. Now what I want over this noise mask, what I want is that my 2D transform, my offset, is applied only on squared of 64 by 64. So over this 2D noise, I will add a little stylized modifier that is a pixelate. And it has only one parameter, its value, which is the size of pixel you want to have. So we want 64 by 64. And there you have it. On each different tile, you have your LED mapping that is fucked up. Let's re-put the input test pattern, and there you have it. Now what I wanted to do is simulate, alors, that you can do it this way to make it random over your all LEDs. What you can do also is not making random. So like for instance, let's duplicate this mask, keep this one in reserve, and let's change this mask here, not for a parallel noise, but for a linear gradient, JKL linear gradient, and visualize what it is. So now I have my linear gradient that is pixelated, like that. Okay. And let's put this composition in fucking sRGB to have a correct gradient. Not quite. Is my gradient still in linear? Probably so. Well, whatever. So here you have a gradient, and we can even diminish the size, or change the brightness, contrast, gamma here, and here you can make some scrambling around like that. So here, for instance, here my modifier will be, my offset will be at the maximum, and here at the minimum. Let's add a brightness, contrast, gamma over that, and try to make it okay. So that's another way to jerk around with this kind of transformation. So now what I want to do is the last example of this tutorial, to not make it too long, is to create latency issues. So let's remove this viewport, keep only one, visualize, okay, and let's create a new composition. Composition, and call that latency. All right. So in the latency issues, I will put back an image. Let's duplicate this one, for instance. Control, drag and drop. Here it is, and create it, and again send one in electronic. Call that glitch again. A very easy way to do to create also a calibration issue is just to add a little RGB or a little temperature, and just scramble around some parameters to put that just on one electronic or one strip LED, again with a placement mask or checkerboard one. But we are going to create a little bit of latency here. So what we can do to do that is to create, to show how it works, let me just take back also the little smoke. Alright, so in the glitch here, I will add a little utility modifier, which is the frame delay. And let's delay that 5 frames, for instance. So here you already see like some scramble happening. Now let's take back the 2D transforms that we use, but not the 2D transform. We take one of the layer mask. I'll take the one with the noise. So let's control, drag and drop that over the, okay, and let's drag and drop that after the frame delay. It doesn't work. Why? Why doesn't you want to put the fucking mask over the frame delay? Ah, no, I'm stupid. That's exactly what I wanted to do. Not to put it on frame delay, it has no sense. But to put it on the parametric. So that's fine. And now what you will have here, up, and let's put the same on the correct. So you see, like here, we have some latency differences. Let's put 10. So we have some latency differences, but the issue is that we also see, as I'm using a mask that is in black and white, and I'm using that over this composition, then we have this kind of like also transparency effect. It's nice to simulate some error in the tiles, but it does not really fit with the frame delay. I can, but let's remove to just keep frame delay and remove this little difference of brightness. And to do that, it's easy. It's just that my perla noise here. Alors let's vertical split to see again input and output. My perla noise, I want it here to be either black or white. So what I am going to do in the gradient is go in advanced and quantize. And what the quantize will do, if we remove the pixelate, it will just create a noise that is pure black and white. Also in the quantize parameter here, like in any gradient, you have quantize parameter, you can change the step also, which have no purpose here. So let's put that back in 2 steps and put back the pixelate. Okay, and now you have like some tiles that randomly have some frame delay. Again, I did that here with the noise. I can also, on my glitch with the frame delay, just put a little layer mask, change that to a checkerboard, and in the checkerboard, just change my line to have like 1 line out of 2, for instance, or whatever. So technique remains the same. But that's, I think, cover it, not all. You can make a lot more of glitches using imagination. I don't know all working case, but that's it for now. I hope that this tutorial has been somewhat useful, and that next gig, just before the beginning of the show, you can put the prank to your own risk and whatever. Have a good night.